So here we have the heart, the atria on top with relatively thin walls. It's still made of myocardium, but you can see the walls are relatively thin. And the ventricles at the bottom with much thicker walls. And we can demonstrate that if we open the heart. And when we open the heart, we can see the thick muscular walls of the myocardium. So that nice thick wall there will be the wall of the left ventricle. And this bit in the middle we can see here is the cardiac septum between the two ventricles. So here we see the papillary muscles lining the inside of the left ventricle, controlling in humans the mitral valve or the bicuspid valve there. And we can see round about there, that's the whole muscular wall of the left ventricle, including the cardiac septum. And this wall, of course, this muscular wall is thick because it must pump blood all around the body, all around the systemic circulation. So in humans, this is generating a pressure of about 120 millimeters of mercury, because normal human blood pressure is about 120/80, so that's contracting. And by contrast, this chamber here is the right ventricle, and we can see very nicely there the chordae tendineae, the tendinous cords, and I think we can see on that one it's connected to a papillary muscle there. So the tendinous cord will go from the papillary muscle, the tendinous cord up there, and of course the tendinous cord is attached to, in the right ventricle, in humans it's going to be the tricuspid valve. So there's the underside of the tricuspid valve. But we can see how much thinner the wall of the right ventricle is compared to the wall of the left ventricle, because the right ventricle is only pumping blood to the pulmonary circulation, through the pulmonary artery, only to the lungs. And that's not as far to go as it is to pump blood all around the systemic circulation, which is the role of the left ventricle. Very good view there of papillary muscles and tendinous cords in the right ventricle. So there we have it, an amazing pump. Pity this one's dead, but human hearts are very similar to this in essence. All vertebrate mammalian anatomy is really quite similar in terms of gross morphology. So always worth, if animals are dead anyway, having a look, and it really can teach you quite a lot about the nature of anatomical structures.